Can you see my canvas web page?
Yeah, we see the screen.
Okay, this is the canvas web page. I'm going to show you where you can get resources for chapter 3 and 4. Module 2. You click on here, module 2. So we go to module 2 right here. When you go down the module 2, at the bottom there's a sample questions for chapter 3 and 4. You can watch this video about chapter 3, question and answers. Last year I discussed about it. I'm going to add a chapter 3 for this year. It will be, so these are the, we go on all this. Let's go to the problems. We talked about the octet rule. Octet rule is the idea that 8 valence electrons are stable, except period 1. Helium has only 2 electrons. For which of the following listed number of valence electron correct? Aluminum is group 3A. 3A means 3 valence electrons. Chlorine is in 7A. Therefore, 5 valence electron is wrong. Silicon is in 4A. Therefore, it should be 4, not 2. If silicon was on 2A, that's correct. So, correct answer is A. I'm not going to go through all of them. The appropriate number of valence electrons present from the resistor. Choose the appropriate number of valence. 1A is 1 electron, that's correct. 3A is 3 electron. 5A is 5. 7 is 7A. This is for the group 5A. The answer is C. 5A has 5 valence electrons. The periodic table, we need to know there are main groups. Main groups are the 1, 2, 3, 4, 5, 6, 7, up to 7. These are called main groups. Octet rule applies to them, not to the transition metal or lanthanide, actinide, or noble gases. Noble gases have already 8 electrons. So normally octet rule applies to main group elements. Which is most likely correct for an atom with 6 valence electrons. If an atom has more than 4 electrons, less than 4 electrons, less than 4, they lose. Normally, they don't lose all 4. Normally, less than 4 is 1, 2, 3, 4. Normally, they make plus 1 is 1 electron, 1A, 2A, 2 plus cation. If it is greater than 4, they will gain. Greater than 4 is 5, 6, 7. If there are 7 electrons, they will gain an electron, become an ion. Okay, 6 valence electron means greater than 4. They gain electron, they gain to get the octet. Therefore, will gain 2 electrons. B is the correct answer. If valence electrons is same idea, 1 valence electron, it will gain one electron, right? If there's a 1 electron, it will lose that the C is the correct answer. It will lose one electron. So if an element in group 1A and 7A of the periodic table, 1A will be positive 1, 7A would be negative 1. So correct answer is E. Now, I shown the main groups, 7, 1A, 2A, 3A, 4A, 6A, 7A. 7 of them, except the noble gas. Bonding in the main group will lose, gain, share. Losing, gaining will make ionic bond, cation and anions. Sharing will be a covalent bond. So answer is D. We talk about it. Ionic bond is attraction between cations and anions formed by electron transfer, electron loss and gain. Covalent bond is sharing one or more electrons. A pair of electrons shared is one covalent bond. 2 electrons is 2 covalent bonds. So this diagram shows how they are shared and got an octet for the central atom. Except hydrogen, all other main group elements gain 8 electrons. For example, all these hydrogens have 2 electrons. That's the bonding electron. Which pair of elements will form ionic compound? Ionic compounds are made formed between metal and non-metal, right? Metals have lower electronegativity. Non-metals have high electronegativity. Low electronegativity metals lose electrons, gain electrons, non-metals. C the correct answer. Metal and a metal is not a ionic bond, it's a metallic bond. Non-metal and non-metal is a covalent bond. Semi-metals and non-metal, semi-metals are similar to non-metals. Therefore, ionic compound is formed metal between metal and non-metal. C is the correct answer. Ionic bond is formed between oppositely charged species. Remember we talked about cation and anion. Covalent bond is not associated with the following. Covalent bond could be equal sharing of electrons, non-polar covalent bond. Unequal when the electronegativity difference is greater than 0.5, between 0.5 and 1.9. Remember we have range. So answer to this is covalent bond is not associated with the transfer of electron. Ionic compounds, metal, non-metals, are the only one. Therefore, answer is D. Electronegativity. I am going to give you a table with all the values for main group. Therefore, if I ask a question, what kind of bond is formed between sodium and chloride? You get the sodium's electronegativity, chlorine's electronegativity. Chlorine is higher subtracted lower electronegativity. If the difference is greater than 1.9, as the ionic bond. So we talked about this. Normally electronegativity increases going across the period. Going from bottom of a group to top of the group, electronegativity. Highest electronegativity is right here. Lowest is here. They increase this way. This table is in the test. Look at that. This table is going to be on the test. So you have the values. Therefore, you can subtract. You can tell whether bond is ionic, polar covalent bond, or non-polar covalent. Those three things you can tell. I gave you the range. Greater than 1.9 is ionic bond. Less than 0.5, 0.5, 0.0 to 0.5 is non-polar. 0.5 to 1.9 is polar covalent. Covalent bond is associated with which of the following? Sharing electron. Transfer electron is wrong. Interaction between nuclei. Covalent bond is not formed between interaction with the nuclei, with the electron sharing. Therefore, answer is sharing electron B. The metal have lower electronegativity than the non-metal. Remember we talked about metal have low electronegativity than? That's the correct answer. Which of the pair is number 16? Which of the likely to form ionic compound? Ionic bond is formed between metal and non-metal. Therefore, potassium chloride between potassium and chlorine. Potassium chloride is formed. That's the correct answer. In bonding, main group elements gain loose electron to attain the electron configuration of the nearest noble gas. Hydrogen become helium. All other elements become whatever. Sodium will go back to neon. Chlorine will go forward to argon. Succeeding, preceding. Which of the following occurs when an ionic bond is formed? Electron transfer from more electronegative element to less electronegative element. That's not true. Electron transfer from less electronegative, that's the correct answer. Once I get one, for sure one answer, you stick with that and check the other ones if there's something. The bond between AB considered to be ionic. Ionic is electronegativity difference is 1.9. Remember that I talked about it? 1.9 is the ionic bond. Polar covalent bond is 0 and 1.5. Covalent bond, non-polar covalent bond is, answer is D. Metals are found in the left side of the periodic table. Non-metal periodic table is over there. Non-metals are in the left side. Covalent bond between non-metal are on the right side. Non-metal, right. Non-metals are on the right side. Right. I'm going to go to question 21. Which of the elements generally have high electronegativity? Rare earth metals, transition metals, alkali metals are all metals. They have lower. Halogens are non-metals. Therefore, they have high electronegativity. Answer. Naming ionic compounds. Naming cations. Main groups, metals, alkali metal, alkaline earth metal, 1A, 2A, 3A are the ones forming cation. Their name is just the element name, ion, magnesium ion, potassium ion. But the Correct symbol should be there. How do I get 2 plus for magnesium? Is in group 2A. 2A means lose 2 electrons. So all these are main group. When they are naming, they have fixed charges, only one charge. Therefore, you don't put parentheses in the name. But when you have transition metals and lanthanide, actinide elements, they can have more than one charge. When you have more than one charge, you put a parenthesis and Roman numeral 3 for 3 plus. 2 plus is Roman numeral 2, like that. So, naming main group metals, transition metals, and lanthanide actinides are different. So first you have to name the cation. Then anion is one having the negative charge. Anion name is K. If an atom gains an electron, the name is changed to I. The suffix I. Normally hydrogen. You take out the En, hydride, fluoride, bromide, iodine, sulfide. These are monoatomic anions. We talked about monoatomic cations also, main group. So to name, let's see, which of the following atoms is the least likely to form an anion? Chlorine, potassium, iron. Potassium is a metal, it will form ion, cation. Chlorine will form chloride, negative ion, anion. Iron is a transition metal, plus 2 or plus 3 charges. Phenon is a noble gas. Therefore, it is least likely to. That's the answer for that. That's the basis of electronegativity. Number 34. Which of the following element is most likely to lose the electron to become a cation? If you look at argon, that's never lose electron. Sulfur is a non-metal. It will gain an electron, make an ion. Iodine is a non-metal. It makes an ion, not a cation. D is the only answer. Magnesium. It's a metal, right? Metals lose electron and make cation. Number 37. Which of the following occurs when a calcium atom is converted to calcium 2 plus? Calcium loses 2 electrons. That's what you are looking for. Calcium atom gains 2 electrons. That's wrong. Calcium atom loses 2 electrons and 2 protons. Atom never lose protons, only electrons. Therefore, it's wrong answer. D. Calcium atom loses 2 electrons. That's the correct answer, D. Now we have monoatomic cations, monoatomic anions. We have also charged particles called polyatomic ions. Polyatomic ions are group of atoms. Polyatomic is a poly. So we have to remember these names. Only polyatomic cation is ammonium ion, NH4. Hydroxide. We go on over this. You have to remember these names. Now we are coming to naming ionic compounds. You say the cation name first, anion name. For example, ammonium chloride. Chloride ion is negative. That's how we say ammonium chloride name. From the formula, you can get the name. Group 7A element charge is -1. Question number 31. Group 7A charge 7A is halogen group. C is the correct answer. Now, this is very important question. Fe2O3. How do you find the charge on the iron atom? Oxide is 2 minus. There are 3 of them. Therefore, total charge on Fe2, 2 iron atom is 6. Therefore, 1 iron atom each is equal to 3 plus 3. That's how you get the C as the correct answer. Charge on oxide is 2 negative. There are 3 of them that become -6. Therefore, 2 iron atoms should have a total of positive 6. Each iron atom has 3 plus. Which of the following ionic compound cation with the positive one? Positive one should be group 1A. Group 1A. So only group 1A is this. Group 2A, group 2A. Thallium is somewhere. Thallium is sulfur group. So only correct answer is positive charge is A. How do you name from the formula? This is magnesium oxide. Magnesium oxide. You don't use prefixes, monoxide. In ionic compound, you never use prefixes in ionic compound. Covalent compound, we use carbon dioxide. Answer is C, magnesium oxide. Barium iodide. Answer is B. Number 74. Formula of a compound formed between barium and oxygen. Barium is group 2A, 2 plus. Barium 2 plus. Oxide is 2 minus. Therefore, charge is balanced. You just write the barium oxide. BaO. Answer is D. None of these are correct. Barium oxide, the BaO is the correct answer, D. What is the correct name of KCl? Potassium chloride. Answer is C. What is the correct formula for aluminum oxide? Aluminum is 3 plus, oxygen is 2 minus, we cross multiply. Remember we talked about this? This number was here, charge number. So you get Al2O3. It's a D. These are similar questions. You go back and do them. Okay? If I am to go through each every one, we may not have time. So I have to move on. The name of the ion ending A is most likely be sulfate, phosphate, carbonate. These are polyatomic anions. So polyatomic anions is the correct answer. C. A. Sulfate, nitrate, phosphate, carbonate. Only Ide means hydroxide, polyatomic. OH is same as chloride. Only ide is for the polyatomic containing the element nitrogen and hydrogen. Choose the appropriate polyatomic ion between nitrogen and hydrogen is ammonium ion. NH4 first. That's the between nitrogen and hydrogen ion. Polyatomic ion is only positive one. B is the correct answer. Polyatomic ion that contains 3 hydrogen, 3 oxygen atom. Number 58. Nitrate ion, NO3. Polyatomic ion that contains between nitrogen and oxygen contains 2 oxygen is nitrite, NO2. Sulfate ion contains 2 negative, right? Sulfur and 4 oxygen. For the polyatomic ion that has negative 2 charge, nitrate is ammonium ion is hydroxide is negative 1. Ammonium ion is positive 1. Nitrate is negative 1. Sulfate is negative 2. Remember that table we got for polyatomic ion. Bicarbonate, hydrogen carbonate. Systematic name is hydrogen carbonate. It's also called bicarbonate. Hydrogen sulfate, bisulfate, dihydrogen sulfate. We have ions with hydrogen. Bicarbonate is HCO3 negative. Ide is associated always with anions, monoatomic. Ide is found in hydroxide. That's not, this is phosphate, this is acetate, hydroxide, sulfate. All other polyatomic ions have A, sulfate, phosphate, except ide for OH. Formula of the sulfate ion is nitrate ion. This is the correct answer. Sulfate, nitrate, phosphate. This is correct. This is wrong. Why? 2 negative. Phosphate has 3 negative. Phosphate ion has 3 negative. Sulfate ion has 2 negative. Nitrate has 1 negative. This is the only correct answer. Okay, make sure you know the charges on the polyatomic ions and the formula. Now I talk about transition metals make more than one cation. Therefore, you have to use a parenthesis in their name. There are 2 systems. Systematic name uses the parenthesis with the charge in Roman numeral, or as ferric means higher charge. Ferrous means lower charge. Ferric means Fe3 plus. Ferrous means Fe2 plus. All the system is called common system. Put in the parenthesis for variable charge cations is called systematic name. Now you have to remember this is some example. These are transition metals except tin. Tin is a main group element. Group 4A, same as carbon. Only tin uses because it has 2 charge cation. It behaves like transition metal. Therefore, you have to tell tin is 2 plus or 4 plus. This is the Roman numeral. 1 is just 1, 2, 3, 4. That's a common. Ik, ik is high charge, S means low charge. Copper oxide is called copper 2 oxide. Cu is oxide is 2 minus, copper has to be 2 plus. 2 minus 2 plus. Therefore, it said to be copper 2 or cupric oxide. This is the systematic name, this is the common name or older name. Iron also has 2 plus ferrous oxide, ferric oxide, 3 plus. Which of the elements have cations with variable charge? You had to look for one in the period transition metal or lanthanide, actinide. We don't ask question about lanthanide, actinide. Which element is in the transition metal? This one. These are our main group. Therefore, iron is the correct answer. Have variable charge. Naming more than one numerical value of the charge is indicated by Roman numeral, right? Roman numeral in parentheses. C is the correct answer. Iron 3 oxide, iron 2 oxide. Which of the following cation has a fixed charge? Fixed charge is main group, except tin. Tin has 2 plus, 4 plus. Calcium is the fixed charge. They are already showing one of the. When you have parentheses, that means they have more than one charge. Alkali metal, alkaline earth metal have fixed charges. What is the common name of copper plus? Common name is copper has copper 1, copper 2 plus. Copper 1 has less charge, it should be Q plus. Q plus. D is the correct answer, Q plus. Less charge. Copper 2 plus have more charge, it should be cupric. So answer should be C here. Which of the following is a ferric ion? Ferric ion is 3 plus. We gone over this enough problem. Go through this. Now naming is the important thing. Which of the following formula compound represent the we didn't go with lithium boramide is lithium Br, barium iodide is BaI2. Why this is BaI2? Charge need to be balanced. 1 here goes to barium, 2 here goes to iodide. The charge number. There's a 1 here, negative 1. That 1 goes to barium. We talked about this. What is the correct systematic name of iron carbonate? Carbonate is 2 minus, Fe is 2 plus. Therefore, iron carbonate, iron 2 plus. D is the correct name. Go through naming variable, naming compound with variable charge, cations. We gone over this. Sodium nitrate, calcium carbonate. You tell the name of the sodium ion, negative ion, nitrate, then sodium nitrate. If it is transition metal, you have to put the parentheses. So that's how you got these names. ammonium hydroxide, iron carbonate, ferric. First one is systematic, variable charge cations. Second one is a common older system. Some of the names of acids. Sulfuric acid is H2SO4, HCl is hydrochloric acid, HNO3 is nitric acid. You have to kind of know about acid. Polyatomic ions come from acid. Sulfuric acid, if you put in water, you get sulfate ion. Which of the names of an anion that is part of the ending I? Acid name. If I is a nitrite, nitric acid, nitrate, nitric acid, nitrous acid is the acid with I. A is the correct answer. With hydrogen ion, sulfate ion with formed by hydrogen ion. That's the correct answer. With hydrogen ion, this is one. Sulfate ion is with two hydrogen. That's a B. Now, I'm going to go a little faster. Formation of covalent bonds. We gone over this. Octet rule is how you get it. To draw a Lewis structure, you add all the valence electron on the non-metals. Covalent bonds are formed by non-metals. Pair up electrons to get the octet of electron for all main groups except hydrogen. You share electrons if the structure don't have octet. Lone pairs, non-bonding electron pairs could be shared. Look at this question. How many valence electrons are there? Count how many valence electrons. How many valence electrons? So answer should be what? If you are given a dot symbol, if I ask you valence electron, you count number of valence electrons. Alright? How many covalent bonds are generally formed between oxygen atoms? Oxygen makes 2 bonds, carbon makes 4 bonds, nitrogen makes 3 bonds, fluorine makes 1 bond, hydrogen makes 1 bond, oxygen makes 2 bonds. B is the correct answer. How many total valence electron is in NH4? Nitrogen has 5, hydrogen has 4, 5 plus 4 is 9. If there's a positive charge, that means 1 electron is lost. Therefore, 8 electrons. Answer is 8 electrons. What is the correct Lewis structure of ammonia? Ammonia has 8 electrons. 5 plus 3 is 8. This is the only one which has 8 electrons. This has 6, this has more than 8. That's wrong connectivity. The atom making most bonds should be in the middle, like this. We talked about it. Therefore, correct answer is C. What is the correct Lewis structure of carbon dioxide? If you added up 6, 6, 12 plus 4 is 16. 12 plus 4 is 16. 16 means 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. That's the correct answer. This is not carbon dioxide, nor one oxygen. This is correct connectivity, but this has only 7 electron pairs. 7 electron pairs is 14 electrons. 8 electron pair is 16. So that one is not carbon disulfur. That carbon dioxide. That's sulfur dioxide. Therefore, correct answer is this. Because it has 8 electron pairs or 16 electrons. Each bond is 2 electrons. Correct answer is A. What is the correct structure for water? Water has 6 plus 2, 8. 1, 2, 3, 4. 4 pairs. 4 electron pairs is 8 electrons. This is wrong. Oxygen should be in the middle. This has 3 electron pairs. This has 2. Structure is this. Lewis structure of HCl is D. Chlorine has 7, hydrogen has 1, 8 electrons. That's the 8 electrons around chlorine. Hydrogen cannot have 4 electrons. Hydrogen can have only helium, 2 electrons. This is too many electrons. He is the correct answer. We done the Lewis structures. This ion must be shown in the formula 8 electrons. 8 electrons. 5 plus 4 is 9. 1 positive charge is 1 electron. That's 8 electrons. C is the correct answer. HCN could have how many electrons? 1, 4, 5. 10 electrons. 1, 4, 5 added up. 10 electrons. C. Carbon makes 4 bonds. B is the correct answer. Ethylene has double bond. Ethylene is carbon attached to CH2CH2. Acetylene have triple bond. We look into that. This is acetylene, triple bond. This one is CH2 double bond CH2. There are exceptions to octet rule. One of them is if a valence electron pair number is not even, then the pairing up produce lone electron pairs. NO has 5 plus 4 is 9. You cannot make a pair with 9 electrons. B contains an unpaired electron. Lewis structure is not correct if it has unpaired electron. Unpaired means single electron. If you have 9 electrons, you cannot pair up. 4 pairs plus 1. Sulfur, phosphorus. Group 3 or downwards. Now period 3 has D electron. Phosphorus shows more than 8 electrons. Exception 2. Which one is a non-polar covalent bond? Between less than 0.5. Remember we talked about 0.0 and 0.5 non-polar, 0.5 and 1.9 is polar, greater than 1.9 ionic. Non-polar, B is the correct answer. Which of the polar covalent bond of 2 elements? Polar covalent bond is this. 0.5 and 1.9. We go know this. C the correct answer. Now, this is easy. Naming a covalent compound, you use prefixes. Carbon monoxide, carbon dioxide, sulfur dioxide, prefixes. Except first element, least electronegative element is written first. Carbon is less electronegative than oxygen. Therefore, carbon monoxide, carbon dioxide. Sulfur has less electronegativity, sulfur dioxide. Low electronegativity is written first. Sulfur has less electron. SF2 is sulfur difluoride. This is nitrogen dioxide, dinitrogen tetroxide, prefixes. Nitrogen dioxide, dinitrogen tetroxide. Binary covalent compound. Name of the less electronegativity atom first. Remember, less that's the C is the correct answer. N2O3 dinitrogen trioxide. D is the correct answer. What is the name of this one? Sulfur dichloride. D is the correct answer. Dinitrogen pentoxide is this A. Now I am going to ask a question about resonance. Remember carefully. Resonance is when you can write down double bond between several bonds. Sulfur trioxide. This double bond could be moved to other two places. There are three resonance structures. Carbonate ion. I want you to remember these rules. Only difference is distribution of valence electron. The position of all nuclei must be same. You don't move the atoms. Valence electron, same number of valence electron. Distribution of valence electron. That's important. Resonance structures are shown by the double arrow. Remember this one. When you're writing SOT, which of the following are change in the number of valence electrons. You don't change number of valence electrons. You only distribute. Change in the position of valence electrons. You can change position. Change in the number of protons. You don't do it. Change in the position of atomic nuclei. Only allow this B. Now just read this part. Resonance hybrid. Just go through this. Then we did VSP theory, VSEPR theory, valence shell electron pair repulsion. Linear molecule has 180, linear molecule. I am going to give you a table where you have basic geometrics, linear 180, trigonal planar 120, tetrahedral is 109. Water and ammonia has less than 109. Ammonia has 107. Water has 104. So because of lone pair electron repulsion, this has 109. But this is little low, 107. That's 104. This is trigonal planar. 3 electron volts, 1 plane. 2 electron volts, 1 A. These are the atoms. You can have an atom, you can have a lone pair, valence electron pair. Valence electron is not correct. Either atom or valence electron. Atom of lone pair. That's the correct answer. Angular geometry is associated with two bonds, non-bonding electron pair group. More than correct. Two bonds, one non-bonding, two bonds, one non-bonding. These two are correct. Water has two bonds, two non-bonding. Two bonds and one non-bonding is also one group. Angular geometry. Tetrahedral geometry is 109. Answer is C. Ammonia and pH3 are the same. What is this? Pyramidal, ammonia is pyramidal or trigonal pyramidal. What bond angles associated with trigonal planar distribution? 120. Predicting the polarity. Now we talked about this. The bond, one of the covalent bonds has to be polar, and they shouldn't be distributed to cancel the polar covalent bond. Water is polar. Remember this. Water is polar because there are two lone pairs bonding in polar covalent bond adds up. Ammonia adds up. Ammonia is polar. Dichloromethane is polar. Dichloromethane. Formaldehyde polar because oxygen is one side, two hydrogen. Therefore, at least you have to remember this. Acetylene is non-polar because electron distribution is symmetrical. Besides, it has carbon-hydrogen non-polar bond. Which one is incorrectly assigned? This is correct, this is correct, this is correct. That's not correct. Chlorine has higher electronegativity than iodine. All right, I'm not going to have enough time to go everything. Let me show you what you can do. Basically, I go on over chapter 3. There are chapter 4 videos. There are 3 videos. Just go over there. It will be same thing that I will be going over. You understand? Chapter 3, chapter 4. I go on over almost chapter 3.